Okay, so we have question 1 here, and the question says the apparatus for a simple distillation is shown in figure 1. So I'm going to highlight the key word here, so the key word distillation, and I'm going to have a look at the diagram and see what they've given me. So they give me a round bottom flask, they're heating from the bottom, we've got water out, water in, we've got A labelled, we've got a beaker, and then we have a thermometer. So I'm going to label my thermometer and I'm going to label A as well. Okay, so then it says use words from the box to complete the sentences. You may use each word once, more than once, or not at all. So I can use the word more than once if I think. So I'm going to highlight that as well just to remind myself. Okay, so it says simple distillation is used to separate a liquid from a something. So I know that if I had this diagram here, I could have a liquid and a solid, and I would be able to evaporate off the liquid and leave the solid. So the answer to this one is solid. The second one, it says in the apparatus labelled A, vapour is cooled to form liquid. This process is called, so I know that vapour is cooling to form a liquid, and so that is called condensation. And finally, the liquid collected in the beaker is known as the, well, I know that that is called the distillate. Okay, so part 2. Pure water collects in the beaker. So that's here back on my diagram. So I'm going to put here just to remind myself that this is pure water. Explain. Okay, so I'm going to need to use point and explain for this answer here. So PE, point, explain. Explain how the apparatus will show that the liquid collected is pure water. Okay, so I'm going to explain how the apparatus, so I need to look back at my diagram here, and what on the diagram here will show me that the water that's being collected is pure water. So it's not the flask, it's not the beaker. Okay, so I've got the thermometer here, so I can use the thermometer to show that water is pure water, because I know that pure water boils at 100 degrees. So my point is the apparatus is the thermometer, and I can say that it will read 100 degrees C, which is the boiling point of pure water. Okay, part B. In analysis, tests are carried out on solids dissolved in water. Explain why it's important that the water used is pure. And again, it's an explain question. So again, I'm going to use a point and explain. Okay, so why is it important that when I'm testing solids dissolved in water, that the water that I use is pure? Well, I know that pure water has no other chemicals in it, and the explanation is that other chemicals would give a false result. So that's my 2 marks there, point and explain. Okay, now if I go on to part C, it says a water molecule, H2O, contains 2 hydrogen atoms and 1 oxygen atom. So I've got 2 hydrogens and 1 oxygen. The electrons in the outer shells of a hydrogen atom and an oxygen atom are shown. Draw a dot and cross diagram for a molecule of water. So I know that I need to have 2 hydrogen atoms and I need to have 1 oxygen. So I'm going to draw my oxygen, and that's not very good, and I'm going to draw my hydrogens to the sides. Now I have hydrogen on each side, oxygen in the middle, and they want me to draw a dot and cross diagram, so I'm going to draw on the ones that they've given me. So here's my cross for my hydrogen, and I'm going to add my oxygens. Now both hydrogens and oxygens want to have full outer shells, so hydrogen needs to have one from the oxygen, and this one needs the same, and then I can draw on my other electrons. So oxygen has 1, 2, 3, 4, 5, 6 in its outside shell. There's 1, there's 2, 3, 4, 5, 6. And I can check because hydrogen has got 2 in its outside shell, so it's full. This hydrogen has got 2, it's full, and oxygen now has the 6 plus the 2 from the hydrogens, so 8, so it's full. So finally for this question, I need to balance the equation. So the best way to do this is to look at the atoms that I have on the left and the right hand side. So I know that I've got hydrogen and I've got oxygen. At the moment, I've got 2 hydrogens on the left and 2 on the right, and I've got 2 oxygens on the left and 1 on the right. So my oxygens aren't balanced. The other thing that's easy to do is draw a little box around these, so that reminds you that you can't change these formula. H2 always comes as H2. I can't suddenly make that H3 or H4. H2O is always H2O. I can't make that H4O or H3O2 or something. So by drawing a box around it just reminds me I can't change those. So what I need to have is more oxygens on the right. So I can put a 2 in front of my H2O, which means that I now have 4 hydrogens and 2 oxygens. So my oxygens are now balanced, but my hydrogens aren't. So I now need 2 more hydrogens on this side on the left. So if I put a 2 there, I've now got 4 hydrogens on each side and 2 oxygens on each side. So my equation is balanced.